All right, so let's go over these problems. And you're going to notice that I kind of follow the same set of steps with every single problem that we do. The first thing that I'm going to do is I'm going to figure out what my variables are or what my variables mean in the problem. Then I'm going to set up my system of equations, and then I'm going to solve. Okay, so just like what you did the other day with the word problems, that's how these work. All right, so with number 1, it says a math club is selling candy bars and drinks during football games. It says 60 candy bars and 110 drinks will sell for $265. If you sell 120 candy bars and 90 drinks, that will sell for $270. It says how much does each candy bar sell for? So they're only concerned with the candy bars, but just like the other problems, a lot of times we're going to end up finding other information along the way, okay? And then the other important information to kind of realize here is this would be one of those that you would not have a calculator for. So you'd have to know how to do it without the calculator, okay? So what are our variables here? Well, in this problem, it's asking how much does a candy bar sell for? So that will be one of our variables. And so just like the other problems where I make my variable kind of help me to remember what it means, for candy bar, I'm going to put a C. So C, and go to the side, would be, I guess, how much a candy bar would sell for. So cost of, or price of, however you want to write it, cost of a candy bar. And then the other thing that they're talking about in this problem is how much the drinks will sell for. So we will have to have, because that's part of our equation, we will have to have a variable for that. So I'll put a D for drinks, okay? So this would be the cost, or how much a drink would sell for. So cost of a drink, okay? So that's the first step. Tell what your variables mean. From there, you will set up your equations. And so I'm going to set up my equation over here so I have a little bit of room to work. So in this first one, and this is one that it kind of sets it up for you, so all you have to do is just write it down. So it says when they had 60 candy bars, so if you take 60 times how much a candy bar cost, and 110 drinks, so it'd be 110 times the cost of a drink, that it says that they would have sold it for a total of 265. So that equation would be 60 times C plus 110 times D equals 265. Okay, so then the other equation, it says they sold 100, if they sold 120 candy bars, so that'd be 120 C and 90 drinks, so plus 90 drinks, it ended up selling for a total of $270. Okay, so there's our equations, and then we have to solve. So typically, you know, when we have it in this form, if you think about all the different ways that we can solve a system of equations, you have substitution, you have graphing, you have elimination. When it's in this form where all your variables are lined up and your equals are lined up, we would use elimination. So that's what I'm going to do. So you're going to look at the problem, you're going to figure out what you can do, and usually we would do the flip-flop method, but remember, your goal is to end up with one of your variables having the same number with different signs in front. So if I did the flip-flop method, that would give me some really big numbers, and I don't have a calculator for this problem, so I'm going to have to look at it and see if there's a way I can do it where I don't end up with having to get big numbers, okay? You can always avoid that, but if I look at this problem, if I look at the numbers in front of C, they're not the same, but if I take, for instance, the 60 and I multiply it by 2, I'll get 120. So I can at least get this number to be the same in front. But then also remember they have to have different signs, and right now they're both positive. And so when I take this and I multiply it by 2, remember you take the whole equation and do that, I have to also put a negative with it so that it'll make this have a different sign, okay? And so remember your goal is to get them have the same number with different signs. And if I take that times 2, that'll do that, okay? So just like what we did with elimination, you take that number and you distribute it to the entire equation. And so I'm going to do that. So negative 2 times 60 ends up being negative 120. And then negative 2 times the 110, that would be a negative 220. And now this one might be a little harder for you to kind of calculate. So I'm going to take the negative 2 times the 265. I know it's going to be negative, so I'm going to go ahead and put a negative. But if you're not sure what that would be, if you multiply it by 2, you could just go to the side, do a little work like you did in elementary school. Okay, so it'd be 2 times 5, which is 10. And then you got to carry the 1. 2 times 6 is 12, plus that 1 is 13. And then 2 times 2 is 4, plus 1 is 5. So from there, negative 2 times the 265 ends up being negative 530. Okay, so now we have what we want. We have the same number, different signs. So once you do that, you add them. So 120C minus 120C, that goes away, which is what you want to happen. And then 90 minus 220, you'll have to kind of think through that. You can think about it, okay, which one's bigger? The 220 is bigger, so you know it's going to be negative. And then you could take 220 minus 90, and you would get 130, okay? And so that's 130D. And then here you've got 270 minus 530. And so again, you'd kind of have to think through that, and you could go to the side and do a little subtraction if you wanted to, but the bigger number is negative, so the answer will be negative. And then you could take 530 minus 270, and you will figure out that that ends up being 260. Okay, and then from there, you've got to keep solving. So we're multiplying by negative 130, so the opposite would be to divide by negative 130, and so those will go away, and then you'll be left with D equals, and then negative 260 over negative 130 ends up being 2. Okay, so now after you do all that, go over here and make sure you remember what your variables mean. So the D was the cost of a drink, so we found the cost of a drink, but that's not what this problem's asking for. It's asking what is the cost of a candy bar, or what are we selling candy bars for. So that means we're going to have to come back over here and pick one of my equations and plug it in. Okay, and again, you could pick either one. I usually just pick the one that looks easier, and so they both kind of look a little complicated, so I'm just going to pick this first one here. So you take that equation and you copy it down. And then whenever you get to D, you're going to plug in what you got for D. So it'd be 110 times 2, because that's my cost of a drink. And then I copy down the rest of it. And then I just have to simplify. So my 60C will come down. 110 times 2 is 220. And then I've got to subtract my 220 to both sides, because I've got to start getting my C by itself. These go away. My 60C will come down. And then 265 minus 220 is 45. And then I have to divide by 60. So C would be whatever 45 over 60 is. Okay. So reduce that. So think about what number goes into both of these. And I'm going to put a little dividing line here. So you can kind of think through it and think to yourself, okay, well, I noticed that maybe, and if you're not sure what the biggest number is that goes into it, start kind of reducing it by what you do know. So I know that the 5 will go into both of those. So if I take 45 and divide it by 5, I get 9. If I take 60 and divide it by 5, I get 12. And so then you look at that fraction. Is there a number that will go into both of those? And there is. And so you could take, okay, 3 will go into both of those. So how many times does it go into 9? It goes 3 times. How many times does it go into 12? 4 times. And then notice you can't reduce anymore, okay? And so that would be our answer, but go back and look at what that variable means. C is the cost of a candy bar. So you actually want to write that as a decimal, because when we talk about the cost of things, it's written as money, which are decimals. And so 3/4 is actually 0.75. So the answer here would be the cost of a candy bar is 75 cents. So cost of a candy bar is 75 cents. So there you go. So make sure you actually write down kind of a little side sentence saying what that number means. All right, the next one. This one is ones that we've kind of touched on, but we touched on in a different way. And so this time you're actually setting up systems, all right? So in this one it says the sum of two numbers is 28. The difference is 4. What are the numbers? So the sum means that you're adding them. And then the difference of them means that you're subtracting them, okay? And you don't know what the numbers are, and so you're finding them. So you could use an x and a y. And you're going to have x is one of your numbers, and the y is the other one. So because their difference is 4, that means one of them is going to be bigger and one of them is going to be smaller. So if you want to kind of define it in that way, you could say, okay, x could be my bigger number, and then y would be the smaller number. Or you could just say x is one of the numbers and then y is the other number, okay? It doesn't really matter. You just need to kind of define them in some way. So it's saying when we add them, it's 28. So you're going to take x plus y. You're going to take them and add them, and you know that's going to be 28. And then it says their difference is 4. So that means when you subtract them, you get 4. Now, because of the way that I've defined them, to get a positive 4...
Can you meet me in the front office? Christy Graybill.
To get a positive 4, you have to take the bigger minus the smaller number. So when I take x minus y, I get 4, okay? Then you solve. And so this one, you'll notice, is actually very easy to solve because it's actually set up, if you look at the y, to do elimination right off the bat, because the y has the same number with different signs in front. And so you can actually go ahead and, excuse me, go ahead and add them to be able to solve it. So when I add them, this will go away, and then x plus x is 2x, and then 28 plus 4 is 32. So I just added them, and then you've got to solve, so you got to divide by 2, so x is 16. So if I look over here, that's the bigger number. And I have to find both numbers, so that's my bigger one. And then you can use either one of these equations to find the other one. So I know if I take and add them, it's supposed to be 28. Or if I subtract them, it's supposed to be 4. This would be the easier equation to plug in. So I'd take 16 plus y equals 28. And then I'd have to subtract my 16. And so y ends up being 12. And so my numbers would be 12 and 16. So there we go. Okay. The next one will work a very similar way. Okay. Same type of problem. It says the sum of two numbers is 24 and their difference is 2. And then it's asking what the two numbers are. So you can do this one, kind of set it up the same way. X could be like your bigger number. And then y could be your smaller number. Okay. And then it says the sum of them, which means when you add them, it's 24. So if I take x plus y, it'll equal 24. And then it says their difference, which means you're subtracting them, is 2. And so since you're getting a positive number for the difference, you have to take the bigger number first. So it'd be x minus y equals 2. And then it's just like the last one. It's actually kind of set up nicely to go ahead and do elimination because of the y has the same number with different signs. So you can add them, and those will go away. So you end up with 2x equals 24 plus 2 is 26. And then you divide by 2, so x is 13. Okay, so that, notice, is my bigger number, so now I have to find my smaller number. So I know if I add them, so if I take 13 plus the smaller number, it should equal 24. And then I could just subtract my 13. So when I subtract my 13, I end up getting 11. So my two numbers are 11 and 13. Okay, so those are a certain type of problem you could see. So number 4 is kind of switching gears. This is kind of going off of what you would have learned earlier in this class. So number 4 says 2 times Antonio's age plus 3 times Sarah's age equals 34. Sarah's age is also 5 times Antonio's age. Okay, so you're talking about their ages, and then it says, how old is Sarah? And then this is another one where they will not let you use the calculator for, so you'll have to know how to do it without the calculator, okay? So, because we're talking about their ages, I'm going to put a letter for Antonio's age, so I'm going to put an A for that. So, A would be Antonio's age. And then they're talking about Sarah's age, so I'm going to put an S for Sarah's age. And then I'm going to look back at my problem and kind of figure out what it's saying. Okay, so it says 2 times Antonio's age. So if you take 2 times A plus, so that means add, 3 times Sarah's age, so 3 times Sarah's age is equal to 34. So that kind of sets up the equation for us. So 2 times A plus 3 times S equals 34. Okay, so that's that equation. Then, and that looks like a 5, so let me see if I'll just write it as like a lowercase letter. It says Sarah's age is also 5 times Antonio's age. So what that means is if you take 5 times however old Antonio is, you'll get Sarah's age. So Sarah's age is 5 times Antonio's age, okay? So from there, you're going to look at it just like the other ones, and you're going to figure out what's a good way to solve it. All the ones before this, it was really easy to do substitution because they were kind of already set up to do substitution with. However, this one is not necessarily set up that way. So this one is actually set up more so to where you could do, the other ones were for elimination. This one is set up actually so you can do substitution easily because notice you have a variable equal to something. So with substitution, that's where you take whatever that variable is equal to. So in this case, the S is equal to the 5A, and you plug that in the other equation for that variable. So S is the same thing as this. So in the other equation, instead of S, we're going to write that. Okay, so we're going to take this 5A and we're going to plug it in for that S right there. Okay, so I'm going to rewrite that equation. So 2A plus 3 times, and when I get to the S part, I'm going to plug in my 5A. So it'd be 3 times 5A, and then I copy down the rest of that equation. So substitution, you take whatever it's equal to and plug it in the other equation for that variable. Okay, then you just solve. So I'm going to simplify this part. So I'm just going to bring the 2A down. 3 times 5A is 15A, and then equals 34 comes down. Combine like terms, so 2A plus 15A is 17A. And then bring the rest of it down, divide by 17. And A, which is Antonio's age, so make sure you go back and look at what it means, would be 2. Okay, so then from there, if you read the problem, it's not asking for Antonio's age. So make sure you go back and read the problem to see what it's asking for. It's asking for Sarah's age. So that means we have to come back over here and plug this into one of my equations to find it. Now this one looks way easier. So I'm going to take that equation, S equals 5 times, and then Antonio's age was 2. So Sarah's age would be 10. Okay, so you would go over here and you'd say Sarah is 10 years old. And so that would be your answer. Okay. So the next one, it says find the point of intersection between these two. Okay, so look at the setup of it. Decide what would be a good way to solve that. And if you notice, they're all lined up. So that would be an elimination problem, all right? So you're going to look at the numbers in front of your variables and see if anything's happening to where you can do elimination. And this one we're going to have to do something with. If I look at my y values, I notice that they have the same number, we have to make them have different signs. So I'm going to take one of my equations and I'm going to multiply it by -1. And it doesn't really matter which one. Just out of preference, I'm probably going to take the second equation because it's got all negatives, and I know that if I multiply it by -1, it'll get rid of all of them, okay? So it'll work with either one, but I'm going to multiply it by -1 so that my numbers in front of the y have different signs. So I'm going to take my first one and I'm just going to copy it down. because I'm not changing that one. And then I'm going to take my negative 1 and distribute it to everything. So negative 1 times negative 2x is a positive 2x. Negative 1 times negative y is a positive y. Negative 1 times negative 24 is a positive 24. And once I do that, notice I end up with same number, different signs. So now we can do the elimination. So you add them. 3x plus 2x is 5x. My negative y plus y is 0. And then 26 plus 24, that would be 50. Okay, and then divide by 5, got to keep solving. So x equals 10. Okay, so this is saying find the point of intersection. Remember, point of intersection is like if you were solving it by graphing, which you could do. You're looking where they cross, but these are all going to accomplish the same goal, no matter if you do substitution, elimination, or solve by graphing, they get you the same answer. So that's the reason why I know I could still do elimination, is because it's still going to find that point of intersection. Okay, so that's my x value. Now you have to go back and plug it into one of the equations to find the y value. So this one looks a little easier. So it's going to be 3 times my x value, which is 10, minus y equals 26. Then I have to solve. So I've got 3 times 10, which is 30. I have to subtract my 30 to both sides. So then these go away. My negative y comes down. Don't ignore that sign in front of the y. And then 26 minus 30 is negative 4. And then I just have to divide by negative 1. So y is equal to 4. So the point of intersection, the point where those two would cross, would be at 10, 4. So if you actually graphed those and looked at where those two lines crossed, it would cross at the point 10, 4. Okay, so we got 2 more problems just to kind of review and make sure that you know how they work. And these are like the problems that you did the other day. So hopefully these will kind of come back to you. All right, so these are the problems where they're talking about value or like how many. So it says your teacher is giving you a test worth 100 points. The test contains 40 questions. And then it says the test includes 2-point and 4-point questions. It says how many 2-point questions are on the test. So notice it's saying there's 40 questions. So that's how many there are. So that tells me I'm going to be setting up a how many equation. And then it's talking about how much the questions are worth. So this is going to give you information about the value in terms of points. So you're going to have a value equation, okay? So it doesn't really matter which one you set up first. I usually set up the value one. So I'm going to look at the value question. It says the test includes 2-point questions and 4-point questions. So you're going to have the 2 types of questions. So I'm going to put a T for 2-point questions, the number of 2-point questions. So let me make sure I'm a little bit more specific. So this would be the number of 2-point questions there are. And then we've got 4-point questions. So I'm going to put like an F for 4. And this would be the number of 4-point questions. Okay. Then I'm going to set up my equation. So I've got the value equation. All right, so that's dealing with how much they're worth. So I'm looking here. So my 2-point question, for each 2-point question, it's worth 2 points. So if I take 2 times however many 2-point questions there are, plus 4, because that's how much they're worth, times however many 4-point questions there are, so times F, it should be worth a total of, and now this is where you have to kind of be tricky with it. It says that it's worth 100 points. So the total, worth-wise, should be 100 points in all. So that's that equation. And then you've got your how many equation. And that deals with just how many there are in all. So it says that there's 40 questions in all. So if you take the number of 2-point questions, which is T, plus the number of 4-point questions, which is F, it should be 40 questions in all. Okay, and so from there, you solve it. So this is set up for elimination. So I just have to get one of my variables to have the same number with different signs. I'm actually going to take this equation and do something with it, because like if I wanted it to have like a 2 in front, I could just take it and multiply by 2, and then I have to multiply it by -2 because I need them to have different signs. So I'm going to take this equation and multiply it by -2, okay? So I'm just going to copy this one over. So it'd be 2t plus 4f equals 100. And then this one would be, distribute my -2, so it'd be -2t minus 2f equals, and the -2 times 40 is -80. And then we solve. So we add them. -2t minus 2t is 0. 4f minus 2f is 2f. And then 100 minus 80 ends up being 20. Divide by 2, so f is 10. Okay? Go back and look at your problem and look at what it asks. It says how many 2-point questions. That is how many 4-point questions there are. So you're going to have to go back and use one of your equations to find the 2-point questions. So this one's way easier. So I'm going to take this equation and I'm going to write it down, and I'm going to plug in 10 for the f, and then I solve it. So I have to subtract 10. So t would equal 30. So answering my questions, the number of 2-point questions, there were 30 of them. So there's 30 2-point questions. Okay, so last one. This one is actually, if you kind of read through it, this one's set up for you. And so it says you've got shipments of recorders and harmonicas. It says 5 recorders and 4 harmonicas ended up being $62. 10 recorders and 3 harmonicas ended up being $84. And you're finding the cost of a recorder. So go to the side. We have recorders. So that would be like the cost of a recorder. And then H would be the cost of a harmonica. Okay, so you've got 5 recorders, so it's 5 times however much a recorder costs, plus 4 harmonicas. That ended up being a total of $62. Then you had 10 recorders and 3 harmonicas. That ended up being $84. Okay, same story. It's kind of set up for elimination. You could do the flip-flop here, and since we haven't done the flip-flop yet, I'm going to remind you how to do that. So if I did the flip-flop, like you take your numbers that's in front of one of your variables, so like I'll take the 10 and the 5, and you flip-flop them. So the 5 would go down here. You could also have multiplied this one by a -2, and that'll do it too. I'm just reviewing. And then if they have the same sign, you have to put a negative in front of one of them so that they won't have the same sign. Okay? Then you distribute. So if I take my -10 times everything, I end up getting -50R minus 40H equals, and then 62 times -10 ends up being -620. Okay? And then this one, distribute my 5, so it'd be 50R. Notice we had what we wanted to happen there. And then 5 times 3H would be positive 15H. And then 5 times 84 ends up being 420. Okay, and then just double check, make sure that you have the same number of different signs, and if that happened, fantastic, you can do the elimination. So you add them, those would go away. And then -40H plus 15H is -25H. -620 plus 420 ends up being -200. Then you divide by your -25 because you got to get that away from the H. And then H ends up being 8. So now, that's the cost of a harmonica. We're looking for the cost of a recorder. So you got to go back and plug it in. So pick one of the equations. That one looks maybe a little bit easier. I don't know. So we'll take it and we'll plug it in. So it'd be 5R plus 4 times the H is 8 equals 62. And then I simplify. So my 5R will come down. 4 times 8 is 32. Oh, didn't mean to put equals right there. It's 32. I subtract my 32. So then I end up with 5R equals 30. Divide by 5, and R is 6. So the cost of a recorder, getting ahead of myself here, recorder is $6. So there you go.